Welcome everyone to the Hanover Fair Technical Forum at the Hydrogen Fuel Cells and Batteries group exhibit. Today we are going to hear a presentation on AEM Electrolysers by Enapter. So welcome everyone here and also everyone viewing at home. Please grab a seat and enjoy a drink, some juice or water, while we welcome Jan-Justus Schmidt, Head of Operations at Enapter.
Okay, welcome to Enapter. We produce AEM Electrolysers. Now you may not know exactly what that is yet, but stick with me for the next 12 minutes and you'll learn all about what you need to know and you will understand why we believe that AEM Electrolysers are the best solution for on-site generation of hydrogen gas. So I'm sure all of you know that electrolysers are the machines that produce hydrogen gas from water and a source of electricity. We prefer to use renewables like solar or wind. And these electrolysers are the best solution for storing excess power and to give value to otherwise wasted renewables and store them in hydrogen gas for later use. We're all here at Hannover Messe because we believe and we know that hydrogen will play a bigger and bigger part in the energy system of the future. And when we look around the fair, we see a lot of different approaches for the generation, distribution, and use of hydrogen gas. At Enapter, we have a clear path and a mission, and we want to enable clean and green energy security and independence for all energy systems around the world. And we believe our AEM electrolysers is the best way to do this. It's a clear trend that we see power generation across the world is becoming more and more modular. Smaller scale renewables like solar, wind, and other distributed sources are slowly replacing the big monolithic fossil fuel power plants. And we at Enapter are certain that energy storage and hydrogen has to follow the same path. We need systems that are more flexible, that are fast to deploy, and that are easily scalable to any size. We know this is the right approach when we look at batteries. Sure, there are some very big systems being deployed on the grid, but small-scale distributed assets like in batteries in homes and cars seem to be the smarter solution. So Enapter electrolysers are designed following the same philosophy. Our electrolyzer systems are made up of individual units, each producing half a cubic meter or 500 liters of hydrogen gas per hour. They are ideally suited to be stacked together to make systems of half a cubic meter up to 10 cubic meters of hydrogen production per hour. A 10 cubic meter electrolyzer uses only 48 kilowatts of power. The systems are rack mountable, so they can be installed in a standard 19-inch cabinet, and it's easy to scale to any size. So if we need more hydrogen generation, we can simply add an additional stack module. If a cabinet is full, we add another cabinet to have more space for more stack modules. Our electrolysers are very versatile and can be used anywhere that hydrogen is required. So let me take you on a quick tour around the world to show some successful use cases of the AEM electrolysers. First, we have the Pisua House in Thailand, which is a completely off-grid housing development with 4 family homes and other support buildings, completely powered by a hybrid off-grid system with solar, batteries, and a hydrogen. A 2 cubic meter AEM electrolyzer generates hydrogen from excess solar power during the day, and this can be turned back to electricity and fuel cells whenever required. Another project in Malaysia is with Digi, the 3rd largest telco operator in the country. They operate a large number of remote base stations with unstable power supply, and this particular one uses a 1 cubic meter electrolyzer to generate hydrogen gas. When required, fuel cells can then use this hydrogen gas to provide backup power for days on end while the network operators repair the primary power supply. This is a refuge in the French Alps. This site is also completely off the grid, using solar and batteries for the daily operation and hydrogen as a seasonal energy storage. So half a cubic meter of AEM electrolyzer generates hydrogen during the summer months from excess solar, and then fuel cells continue to supply the electricity even during the winter when solar panels oftentimes cover not just the solar panels, but snow covers not just the solar panels, but covers the entire building. So all of these projects use electrolyzers to produce hydrogen, which is then turned back to electricity and fuel cells. These are my favorite projects because they showcase the flexibility in design and the long-term storage capability of hydrogen, which no other technology can do. So at this point, you might be wondering what AEM is, why it works, and why it's the best technology there is for this kind of application. So this is a technical forum, so allow me a few minutes to dive a bit deeper into the technology. AEM stands for Anion Exchange Membrane. And so here on this graphic, we can see the makeup of a cell in our electrolyzer stack. The AEM membrane is sandwiched between a dry cathode and an anode. The anode is where there's a slightly alkaline liquid water solution is circulating. When we apply electricity to this cell, hydrogen gas and OH minus forms at the cathode. OH minus is an anion, which means it can be transported by the anion exchange membrane. It goes over to the anode side, where it completes the reaction to form oxygen and water. So when we continuously apply electricity, more and more hydrogen will form at the cathode side and pressure will build up. This is how we can supply high pressure hydrogen directly from the machine without an additional compressor. Why is AEM really cool? Well, one of the things is that the AEM membrane, unlike PEM, is not acidic. So we don't require noble metals to have good lifetime and good performance. Another thing is that we can use a safe, low concentration alkaline solution. In fact, for our electrolyzer, at the moment we use only 1% KOH in water, compared to other liquid alkaline electrolyzers that use 30% or higher concentration. All of this means that our materials and our systems are easy to handle, and all the components can potentially be made very cost effectively. Lastly, because there's no metal ions and the low alkalinity of our solution, we also eliminate any concern of interaction with CO2, which in conventional electrolysis oftentimes leads to potassium carbonate precipitation and fast degradation. So we don't have any of this issue. So to summarize all of this very shortly, AEM Electrolysers, they present the best option for low cost, great performance, and safe electrolysis. And we at Enapter are ready to deliver them. Our team combines expertise from IT and engineering together with the electrochemistry expertise of the former team of ACTA in Italy, who are the original inventors of the AEM electrolyzer technology. This unique skill set allows us to develop products that are ideally suited for the future of energy. We know the importance of understanding both the system and the environment in that it operates. So this is why the first thing we did was to develop the Enapter energy monitoring solution. Our comprehensive dashboard allows a remote monitoring and control capability. It's powered by a network of sensors and clever microprocessors installed at the site. We have very high, all the communication is very highly secured, and we support Industry 4.0 and IoT communication standards such as OPC UA and others. And lastly, we also developed a mobile application for end users to see what their electrolyzers is up to. If you are interested to see more, you can visit us at our booth D57. It's near the public forum. So Enapter is a fast-growing international startup. We have 22 employees now today, locations in Germany, Italy, and Thailand, and strong partners worldwide. Together, we will reach a new understanding, and we will revolutionize the way people produce, store, and use energy. Thank you.
And thank you very much, Mr. Schmidt. At this point, if we have any questions from the audience, I will bring the microphone down to you so we can all hear. Okay, well, if we have no further questions at this point, I'd like to say thanks once again. That was really enlightening. So that was AEM Electrolysers from Enapter. Feel free to visit them at D57 if any of those burning questions come up. And please hang around and join us. In just a few minutes, we'll have optimal integration of a hydrogen storage and delivery system from Plastic Omnium. So thanks once again.
Thank you very much.